Okay, so, like I said, listen please. Today we're going to talk about greatest common factor. Now, we're not going to just do greatest common factor of numbers because you've done greatest common factor of numbers before. But that's where we're going to start because it's a good place for a good place for us to refresh our memory. So the greatest common factor is the greatest number that is a factor of two or more other numbers. So a factor or factors are a number that multiply to get a product. Okay? So like 2 times 3, 2 and 3 are factors of 6. Okay? 12 has factors of 1, 2, 4, 3, 4, 6, and 12. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Okay? So we're going to talk about greatest common factor, but we're not only going to talk about it as numbers, we're going to actually talk about it as of monomials too. And we'll talk about what monomials are in a few minutes. So, there's 2 ways to find greatest common factor. We can find greatest common factor by a list, or we can find greatest common factor by prime factorizations. So, listing is creating a list. So what we're going to work with today is let's go ahead and do 12 and 32. Okay? So we're going to find the greatest common factors of 12 and 32. So the first thing we can do is we can find the factors of 32. Or sorry, factors of 12. Every number has a factor of 1 and itself. 12 is an even number, so it also has a factor of 2. So 2 times what gets us 12? 6. Good. Okay. And then how about 3? Does 3 work?
Yes.
Yeah, because 3 times 4 is
12.
Okay, so we created a list. Now you may have done this as rainbows.
What? No.
Or something like that? No? Okay.
I just did normal.
Okay. Alright, never mind.
I never did these.
Sorry.
Okay, let's look at 32. Okay, where do we start?
1.
1 and
32.
2.
2 and
I heard it.
16.
2 and 16. 3.
No.
4.
Yes.
4 and
8.
8. Okay. We're just listing the factors. 2 numbers that multiply together to get that number. So 1 and 32 multiply to get 32. 2 and 16 multiply together to get 32. And then 4 and 8 multiply together to get 42. This is a beautiful thing.
Yeah.
Right?
Yeah.
Multiplication chart is a beautiful thing when we're talking about factors, right? Okay. So I've always got those. I've got a couple of them here. If I need to make more copies, if you want a multiplication chart, that's cool. Okay. Now, let's think about common factors. Okay. 1, yes? Okay. 2?
Yes.
Is there a 3?
No.
Okay. Is there a 4?
Yes.
Okay. What about a 6?
No.
8?
No.
12?
No.
16?
No.
32.
No.
So what's the greatest common factor of 12 and 32?
4.
4.
Now I remember.
Okay? So the GCF of 12 and 32 is 4. Now, unfortunately, listing is not the best method when we move into monomials. Okay?
Assuming that means bigger numbers.
Okay, when we move into bigger numbers, when we move into terms that have variables with them. How are you going to list when we're talking about monomials? How are we going to list when we're talking about variables? You're not, right? So, find GCF by prime factors. So we're going to look at factor trees. Okay? So you start with one of your products or one of your numbers at the top. And then we branch off. Okay. So give me factors of 12.
6 and 2.
6 and 2, right? So I get 2, and then I have 6. Which one of these, are either of these prime?
No. No, neither of them are prime because they can't multiply with another number.
Okay.
Oh, yeah, true.
Well, yeah, they
Brooke is telling me 2 is prime.
Oh, yeah.
Okay, Brooke, why is 2 prime?
Because it's only can be multiplied by itself in one.
Very good. The only factors of 2 are 1 in itself. So 2 is prime, so I circle it.
This kind of reminds me of family tree.
Yes.
Oh, this is how
Okay.
Miss Glover
Yeah,
did
this
it.
is
Yeah.
How do we do 6?
3 times 2.
Okay.
And you circle both.
Yeah, because
You circle both because they're both primes, right? So now, for 12, the prime factorization of 12 is 2 times 2 times 3.
9.
So I write down all the primes.
Okay, the buses are all in, so teachers, please go ahead and do attendance. Thank you.
Trey was so mad at school today because of the train.
Oh, yeah, they're true.
He
They're
was
moving.
mad.
What about 32? What are factors of 32?
8 and 4.
8 and 4.
Okay. Are either of those prime?
No.
Nope.
No. Okay, so I have to break them both down. 4 gets broken down into,
2 times 2. And those are both 9.
and those are both prime, so we circle those. Okay, bless you. What about 8?
4 times 2. Circle 2.
No, I just circled. Then. So it would be 2.
Yes, Craig.
So, since 8 and 4 both have 2 in them, could you put 2 for the 4 and then just circle and put it like right in the middle of the 8 and the 4 and circle it?
Because you need all of them. Okay. So when I break down 32 as prime factors, 2 times 2 times 2 times 2 times 2. How many 2's do I need?
5.
This is a lot easier than the other thing.
Yeah.
This doesn't make any sense to me.
Yeah, this is
Okay.
how Mrs. Glover did it.
Yeah, I like this one.
Yeah, but I'm not. Yeah, but who listens to Mrs. Wilkes?
So now we circle whatever they have in common.
The 2's.
Okay? We have a set of 2's in common, so we write it down. Another set of 2's in common, so we write it down. Do we have any other numbers in common? Nope. So 2 times 2 is?
4.
So our greatest common factor is?
4.
Good.
Oh, that's easy.
Oh, okay.
Okay. This is our method. That's our method. Okay? And you'll understand when we turn our paper over why this is our method and why this is the better method. Okay? So let's go ahead and practice with our numbers. Okay? So our first example, we have 4 and 24. Okay? Now, I don't have to do this. I don't have to, right? Oh, on the bottom, yeah, there we go. Okay? I already know that what the greatest common factor between 4 and 24 is. Okay? So when I look at these numbers, but I've been doing this for how many years, right? Okay, well, I'm 36, and I think I
16 years or something.
what? Yeah. Okay, so I've been doing this for a long time. When we do this, we're looking for our prime factorizations. We're looking for our prime numbers that we have in common. So we're going to start with 4. How do we break down 4?
2 times 2.
Right? 2?
They're both prime.
Very good. 2 is a prime. Okay, so I write down 4. My prime factorization is 2 times 2.
Then 24.
24 is
Wait, it can be
6
more
times
than
4.
one.
It can be more than 1. You're exactly right.
But does it
Okay.
matter which?
So let's think about this. I can have, let's look at 24 for a minute.
You can have
12 times 2, 6
Yeah.
times 4.
12 times 2,
8
times
times
4,
3.
3 times 8 times 3, and 8 times 3, 24. There's
And
No,
20
I
times
just did it
4.
by myself.
Okay,
I'm so
2
slow.
and 12,
is
2 and 6, 2 and 3.
Oh, I did it. Oh my god.
Okay, so 24 breaks down into 2 times 2 times 2 times 3. Yes?
I got that same
Yeah.
one.
Okay.
And 6 times 4.
So now, if I do 24, and I do 3
3 times 8.
times 8. Okay, 3 is prime,
4 times
2 and 4, 2 and 2,
Yeah, so
2, 2, 2 and 3.
it's the same. It's just the same thing no matter
Okay.
how
So it doesn't matter which one we use.
Right, so and then 24 I can also use
6 times 4.
4 and 6.
And then and 2 and 2, then 2 and 3, 2 and 3, and then
Wow.
It's the exact same.
It's the exact same thing. Prime factorization is the exact same no matter what factors you use. So for 12, I can use 2 and 6 or 3 and 4. For 24, I can use 2, 12, 8, 3, 4, and 6. It does not matter what you choose. What matters is that you get the correct prime factorization. Okay? So for 24, I'm going to go ahead and go with 4 and 6, 2 and 2,
That makes no sense.
2 and 3.
I have a question.
Wow, that was
Yes,
quick.
Tucker.
So when we order them, do we go from least to greatest?
Absolutely. Okay? So 2 times 2 times 2 times 3.
That's a lot easier than
So now we circle whatever we have in common. Bring it down. Bring it down.
That's so easy.
Anything else in common? No. So we just multiply our factors. So the greatest common factor between 4 and 24 is 4. Is it okay that the greatest common factor is one of our numbers?
Yes.
Yeah, that's fine. Okay? That's totally okay. Is it okay if it's not?
Yes.
Yeah, okay? So go ahead, let's do 2 and 28. Or sorry, let's do number 3. 22 and 38. Let's do that one.
2 is 6.
Okay, why do you think I wanted you to do this one and not this one?
They're both
We're
even.
not necessarily ready for number 2.
Okay? No, you're ready for number 2. Number 2 is easier, right? So when you're looking at 12 and 18, good morning. Oh, put your head down. Thanks. I don't even notice. That's horrible. All right, so
Brady, you're getting her in trouble.
all right, so 22 and 38 may not be as obvious
But
as 12 and 18. Okay? Now, the numbers, the factors of 22 and 38 might not come as readily to you as 12 and 30 or 12 and 18.
isn't that
Okay? So that's why I want you to look at numbers that might not come as easy to you. Okay? So, 22. What do you know about 22?
11 times 2.
Okay, it's an even number, right?
but
So if it's an even number, we know that it is,
multiple by 2?
okay, it's divisible by 2. So 2 and 11.
Oh, so they're both prime numbers.
Okay? They're both prime numbers, right?
You can't multiply.
Okay? Factors of 2 are 1 and 2. Factors of 11, 1 and 11. So they're both prime. All right, what about 38? Well, what do you know about 38? Right now, what do you know?
It's an even number, so you can.
It's an even number, so you know it's divisible by
2.
2.
19.
Oh, but those are both
Prime.
They're both prime. Okay, so my factors of 22 are 2 and 11. My factors of 38, 2 and 19. Okay, we circle what we have in common and we bring it down. Do we have anything else in common?
No.
No.
The greatest common factor is 2.
So our greatest common factor is 2.
Isn't it
The
always
greatest
like
common factor is 11.
2, if they're even numbers, then yeah, the common factor is going to be 2, but it might not be the greatest of the common factors. Because when I look at 12 and 18, they've got a common factor of 2.
Yeah.
Okay, but that's not the greatest of the common factors. So that's why we use prime factorization and we break it down in the way we do. Okay? We feel comfortable with GCF with numbers, yes?
Yeah.
Okay. All right, turn your paper over. Okay, so 6x squared y and 4xy squared. What do you notice?
There's an X, there's a Y, and there's a
Okay,
square.
there's variables and they are
squares?
okay, there's exponents. Very good. Okay, so I made a step-by-step direction for us today. Okay, find the prime factorization of the numbers.
6.
Okay, find the prime factorizations of the variables. List the prime factorization. Circle factors that are common. Okay, so let's start with 6. What's our prime factorization of 6?
2 and 3.
Okay. Okay. What about 4?
2 and 2.
Now our prime factorizations of our variables. What does x squared mean?
It's being multiplied by 2.
It's being multiplied.
So x squared y is actually x times x times. What about this one? What is x y squared?
It would be
X, Y, times X, Y.
Okay. So now we're going to put these two things together. So 6x squared y has a prime factorization of 2 times 3 times y, x times y.
Oh, this is not that hard.
Oh gosh.
Okay. So now, what's the prime factorization of 4? 2 times 2. And what's the prime factorization of xy squared?
X times Y times Y. Wow.
So all we're doing is we're expanding to find the greatest common factors. Okay? So now we list our prime factorizations, which we've done, and now we circle the factors that we have in common. So we've got a 2 in common.
We have an X on it.
We bring it down.
Is there supposed to be a multiplication sign between the 2 and 3?
Oh, yeah, sorry. Okay. Do we have any other numbers in common?
No.
Okay.
We
So
have
now
X.
let's look at our x. Yeah, you're right, Brady.
Yeah.
So we have an x in common, so we're going to circle that,
And then you have a Y in common.
and we bring it down. Okay, any more x's in common?
No.
Nope.
Okay, what about y?
You have one Y.
We have one y in common. So I bring it down. Okay. So, what is the GCF of 6x squared y and 4xy squared? 2xy. Okay? They have a 2 in common, they have an x in common, and they have a y in common.
It's actually way simpler.
That is super easy.
Okay. So again, we're going to list the prime factorizations of our numbers. We're going to list the prime factorizations of our variables. And then we're going to circle anything we have in common. Yes, Zach.
So how come for like x, y squared, you have 2y instead of 2x?
Okay, so in this situation, x is being squared. So that tells me it's x times x. And then we have our y. In this situation, x is not being anything, so it's just to the first power. And then y is being squared, so that's why we have 2y. Okay? So, and those are great questions, you guys. So, when you're looking at the exponent is only, at this point in your math career, it's only attached to that single number or that single variable. Okay? It's not attached to everything here. This is part of the term and this is part of a term. So this is a factor and this is a factor. Okay? So really what happens is x is raised to the first power and y is raised to the first power. We don't write that because we don't need it. So when you see that, I know I just have one x and I have two y's. Here I have two x's and one y. Okay? All right?
So y is squaring the number that's to the left of it.
Yes. Okay. So if I had something
What I don't get is why do they make it so that you don't multiply both of them and make it xy times xy?
because it's only attached to the single variable. Okay? So like this is 2 squared. So that means 2 is being squared. Okay? This is x. Does it have anything with it? No. Okay, so that's an x by itself. This is y to the third. So how many y's would I need?
3.
Okay, and then I have z squared. So how many would I need? 2. Okay, now, here's another thing. If you had this,
Then it would
That's
be
the whole
It'd be
thing.
2.
now that's the whole thing. So that means I have 2 of these. Okay? So that means if I have 2xyz squared, that means I have 2xyz and 2xyz. Okay? So these are raising individually. This is raising an entire term.
Okay.
Okay? This you'll deal with next year. Okay? So these things you will deal with next year, not this year. Okay. Good question, guys. Good extension question. Okay. All right, so let's look at number 1. Number 1 is 10xy and 8x. Okay, so what are we going to break down first? 10. Okay, so let's break down 10. And we're also going to break down
8.
So someone I haven't heard from today. How do I break down 10? Okay. Bob, go ahead.
5 and 2.
5 and 2. Okay. Okay. Now, I put those circles around it for 2 reasons. Okay. One to tell me that it's prime, but then the other, I make sure those numbers are separated so I don't look at that as 52, right? Okay. All right, someone else I haven't heard from today, 8. Okay, how do I break down 8? Danica?
2 and 4.
Okay, 2 and 4. Okay, what's my next step? Someone else? Gabrielle?
To break down 4, which is 2 and 2.
Okay, so I did my numbers. Now what do I need to do? My variables. I have x, y, and I have... Am I breaking down anything here? No, not really. I have x times y and just x. So now I combine my numbers and their variables. So 10xy, okay, breaks down into 2 times 5, and then x times y. Okay, so look at our prime factorization of 8. 2, 2, 2. And my variable is just, what you got, Bob?
Are you supposed to have the multiplication sign and then 5 and 6?
Sorry, I keep forgetting that. Now what do I have in common? Brooke, what do I have in common?
2 x's.
Good. So what's my GCF of 10x, y, and 8x? Shane?
2x.
2x. So okay, here's where I need to be careful. Does that actually equal 2x? No. What does 2x represent?
2 times any number.
Shane, say it louder.
The greatest common factor.
The greatest common factor. Good. So this is actually the greatest common factor.
It would equal that same thing though.
Okay.
10, 8x would equal the neighbor.
No, because you can't combine them.
Craig,
Because
you
this
don't
is
know
an
if-
x and y, and that just has an x.
Yeah, Craig, you don't know if we're adding or subtracting.
Okay. Number 2. What do you see?
12x,
Okay. So 12x squared, and then 15x squared y. What are we doing first?
Finding
prime factorization.
Okay, prime factorizations. So break down 12 and break down 15 for me. Okay? So break down 12 and break down 15. Does anyone want a multiplication chart? Okay? Okay, so I broke down 12 into 2 times 2 times 3. Yes, dear?
Me?
Yeah.
Oh. How come we didn't? I did 2 and 6.
Okay. Did you get the same thing?
Yes. Oh, it's not 2 and 3. Okay. It's
Okay.
just different. Okay.
Yeah, it just looks different because the 2 and the 3 are grouped together. Okay, and then for 15, 3 and 5. Okay, so now we have x squared and x squared y. Okay, Danica, go ahead. Okay. Zach?
X times X times Y.
So now I can list my factors, right? So 12x squared breaks down into 2 times 2 times 3. And then I have times x times x. And then 15 x squared y.
3, 5, split off with this. 3, 5, round the world.
Okay, so 3 times 5. And then,
X times y.
okay,
And the common factor is x.
Three.
Wait, no.
we have any twos in common? No. How about threes?
Yes.
Okay. Fives?
No.
Okay.
And there are two X's.
Thumbs up, thumbs down. Okay. All right. Okay. Yes. Great.
I have to work on my own.
We're doing that right now. Okay. All right. What I want you to do is I want you to do the odds. Okay? Odds only. Okay?
1, 3, 5.
So 1, 3, 5, and then 15 and 17. Okay? Well, don't cross them out. We might use them later. For something. Yeah. Never know.